CI/CD is a scam. Yeah, I said it. CI/CD is a scam. For most projects, it's probably not that useful. Especially if you're doing adventure-driven development, you're doing your first versions and stuff. It's probably not necessary. So I'm going to react to some of these videos about some people that feel the same way I do about the CI/CD stuff and how crazy it can get, and maybe it's not as useful as people make it out to be.
Imagine you're working as a software developer for a company. Imagine you're working as a software developer for a company, an insurance company. This insurance company has clients that are multilingual. So the application for applying for insurances needs to be localized into 5 different languages: English, Spanish, French, German, and Chinese. So this is a well-known pattern. What you create is basically that you create a tiny one table database with a key local value, and then you extract all the specific entities for one particular language in your front end, and then you use this as a lookup to apply values to checkboxes and buttons and text fields, etc. So if you want to do CI/CD on this, then this is a unique project, a microservice if you wish, right? Now, if you want to do CI/CD on this thing, you need multiple environments, right? So you have your development machine, then you have your development environment, then you have your QA environment, then you have your staging environment, and then you have your production environment.
Let's go. Let's do what CI/CD in 5 minutes. Let's look at this. Let's look at this right here. 5 minutes.
What is CI/CD? How does it help us ship faster? Is it worth the hassle? Let's take a look. CI/CD, or continuous integration and continuous delivery, automates the software development process from the initial code commit all the way through to deployment. It eliminates much of the manual human intervention traditionally required to get new code to production. The CI/CD process takes care of building, testing, and deploying new code to production.
Ooh, that's the promise, right? Deployed into production. But there's all these little tests in here. There's all the code commit. You have a human in here that needs to check it off. And did the build, the integration, is it actually testing anything actually real? Do we know if it's going to work end to end? We don't know. That's usually not. That's not industry standard. Do end to end testing, and the deployment does that actually happen automated? Does somebody have to check it here as well?
The promise is that it enables software teams to deploy better quality software faster. Now, this all sounds very good, but does it work in real life? Well, the answer is it depends. Let's break up CI/CD into their own parts and discuss them separately. CI is less controversial and more common. In a nutshell, it is the practice of using automation to enable teams to merge code changes into the shared repository early and often. Each commit triggers an automated workflow on a CI server that runs a series of tasks to make sure the commit is safe to merge into the main branch.
Safe. Again, I think we're putting a lot of stress on these tests and everything that they're safe, and a lot of people just think, "Oh yeah, it's safe, it's fine," but it's not fine, right? That is the head fake. That's the promise that doesn't quite deliver.
A good CI process relies on a good set of tests. It is non-trivial to maintain a set of tests with sufficient coverage and that are not flaky.
Yeah, it's super hard. In fact, it's so hard that maybe we shouldn't try as hard as we have been to try and make sure that's all stuff that works that way. Maybe we should cover the happy path and a couple unhappy paths, and not test every goddamn thing, all the implementations, all the screenshots, really, do we need to test all that stuff? Is that really necessary to test all those things that may not even be tested at all?
High test coverage usually takes longer to run. This impacts developer productivity. It is a tough balancing act, but it's worth the effort to get it right. What are some common tools used in CI?
I've seen people get really good on the bandwagon, this whole testing thing, thinking that that's going to give them quality, when all it does is slow everything down to a crawl and make people want to quit.
A good source code management system is the foundation. GitHub is a very popular example. It should hold everything needed to build the software. This includes source code, test scripts, and script to build the software applications. There are many tools to manage the CI process itself. GitHub Actions and BuildKite are some modern examples. Jenkins, Circle CI, and Travis CI are also common. These tools manage the build and test tasks in CI. There are many test tools for writing and running.
I mean, for back-end code, this is super critical. But for front-end code, I've only worked on 1 or 2 projects that have actually had this kind of testing framework put into it. And it's just kind of slowed things down, honestly. Especially if you're doing a proof of concept or MVP, if you're doing it for the adventure-driven. If you're starting off a project, you definitely do not want to put all this stuff in. Now, for the back end, yes, you want to test every little piece of the code to then make sure it all works in the unit test. But on the front end, maybe you could leave those off there for a while and use some of the screenshot testing, doing end-to-end testing, and like set your platform up to be testable. That's a pretty good. You have test accounts that are only specifically to do this kind of stuff and gets deleted after, or it has a command to delete all the things that are set up for the test for doing end-to-end testing. That seems like that may be worthwhile for the front end. For the back end, yes, you got to do unit tests for everything.
Tests. These tools are usually language and ecosystem specific. For example, for JavaScript, Jest is an example of the unit testing framework, while Playwright and Cypress are some common integration testing frameworks for web applications. The build tools are even more diverse.
People go too far with that stuff.
And ecosystem specific. Gradle is a powerful build tool for Java.
You got to use Gradle. There's no way around it. But I don't know if that's. I mean, everyone just does a different build. Okay.
JavaScript build ecosystem is fragmented and hard to keep track of. Webpack is the standard, but many new build tools claim to be much faster, but they're not yet as extensible.
I'm really a big fan for if you're going to still use HTML-based applications and JavaScript-based applications, is that you try and do buildless or go build free somehow, or minimum build, because this Webpack stuff is ridiculous.
It's Webpack. Now let's examine the CD part of CI/CD. CD is continuous deployment. Now, if we're being truthful, real continuous deployment is hard. They do exist, but the practice is not as common as CI. Many teams only practice CD on the most basic types of systems. These systems are usually stateless, like the API or web server tiers.
And I definitely say that you should do just your deployment is just copy it to your server and go. If you're doing MVPs, or even when you're in your prototypes and MVPs for sure, and maybe version 1.0. Setting up these pipelines. They break all the time. Something goes wrong. There's always some new update, some new library, something new you have to add to it, as opposed to just copying the file to the server and just trusting that your devs are going to do that properly. And also, I want to bring this up right now. Is like we have this shutdown on KTOR. So I'm talking about KMP developers. I'm a KMP developer. The shutdown capabilities. You can do a shutdown command, right? That will let's see if we can find it here. That will you have your shutdown right here, and you can start doing some procedures where you flush the caches, or don't let anybody else log in or log people out, and make, if there's any jobs are running, make sure they run all the way through before they're quit. There's all kinds of ways to do that, right? You don't have to do these sophisticated deployment systems. It's just not necessary. And while you're in, if you're swapping out and you need to bring down a server for a while, you just use a load balancer on the front of the thing. And it'll go to a temporary site saying we're down right now. If you're doing your MVP or your prototype, that's all it's needed. You don't need to be up 24/7. Come on now. But if you get further on, you're gonna, as you do the updates, just try and make it as. All I'm saying is like, this is a lot of stuff is way overdone, and super complicated, very brittle, and no one knows how it works. It's so complicated that no one knows how it works. Anytime you want to change it or modify it, it's like, that guy left 3 weeks ago. It's like, okay, no one knows how. He was the only one that knew how to do it. He had his documentation right here, but it's not. He didn't keep it up to sync. It's like, oh god.
With good production monitoring, these systems could be deployed continuously with minimal risks. They are stateless, and rollbacks are usually quick and harmless. It is also a common practice to wrap new features.
Rollback is, copying the last thing you put up there because something went wrong. It's okay, that's fine. What's wrong with doing that? It doesn't have to be all this automated stuff. This stuff is just, it's so complicated. I mean, you basically have to have somebody to do that. So you're getting out of the adventure-driven mode. Like, why we're just copying the file to the servers, right? We're just copying the file to the server. We can do that in Gradle. We can do that in the build step. We don't have to do all this other stuff. Like, it's just not necessary.
Features in feature flags to separate the deployment of the code from the
most
activation
projects, I think it's just overkill
of the features. This allows the team to quickly shut up new features if they cause any issues without requiring a full rollback. Canary deployment is also common practice for.
So what he's talking about here is these different types of deployment tactics. Different ways of deploying your app. I don't know why it's doing that.
In this video, we're diving into the world of deploying code to production. Nothing beats the satisfaction of seeing our code go live to millions of users. It is always thrilling to see.
That's the whole thing. Hey, you're lucky if you go to if you're not too lucky if you're doing millions of users because you're probably working with a big text and that's probably all you're working on. Some change the color. Now doing your own code and going out to just 5 or 10 users that you got yourself that you sold. Now that is a good feeling. Now doing millions of users, this is the hype. Then it doesn't really. I don't know if that's even real for most people. I mean, I guess, but it's not the same feeling if you've got your own app that you built yourself or built with your team and then you're rolling out to people you sold. That is a good feeling.
But getting there is not always easy. Let's explore some of the common strategies. One of the earliest methods of deploying changes to production is the Big Bang deployment.
And this is what I recommend if you're doing the MVPs and the prototype. Just upload the new file, quit the app, start it over again, okay? And if you have some sort of queuing system, whatever, well, then you already know that those need to be flushed or it needs to continue the job. That's why I was talking about the shutdown command. So you can shut everything down safely and then swap it out, right? I mean, you'll be down for what, a minute? Come on.
Picture it as like ripping off a Band-Aid. We push all our changes at once. This causes a bit of downtime as we have to shut down the old system to switch on the new one.
Yeah. So
the downtime is usually short, but be careful. It can sting if things don't go as planned.
Correct.
Preparation and testing are key.
You want to make sure if you have any queue systems that are in RAM that you've made it so you do a shutdown command or you've put them into a queue that's persistent someplace else. So I mean, got to set that stuff up, right? Come on now.
If it goes wrong, we roll back to the previous version.
Yeah.
Rolling back is not always pain-free though. We still might disrupt users, and there could still be data implication.
Right. So we're talking about you're still at the prototype MVP stage. Like these rollouts don't have to be super sophisticated if you have nobody logged in and you're doing it at midnight.
We need to have a solid rollback plan. Big Bang is sometimes the only choice. For example, when an intricate database upgrade is involved.
Yeah.
Then we have the rolling deployment. It is more like a marathon than a sprint. This method lets us incrementally update different parts of the system over time.
There's like feature flag stuff, so each user could get access to each thing.
It's a staged rollout where we gradually deploy the new version of the application to the production environment.
Canary.
Here's an example of how it might work. Imagine we have 10 servers running our application. In a rolling deployment, we might take down the first server, deploy the new version of our application there, and bring it back online. Once we've confirmed everything is working as expected, we'll move on to the second server, and so on. This approach allows the new version to gradually replace the old one, server by server.
It's a little safer, but still someone's going to get burned. So you got to make sure that whatever rollout that new person's getting, that it's got forward and backwards compatibility, right? So that's always something to keep in mind and keep track of and to be aware of.
Until the entire system is updated.
Especially for app developers who don't have the access to the web. Well, it's just anybody doing front end stuff and given access or doing an API. Yeah, you're gonna have to let your users know and be careful with how that happens.
One big advantage of rolling deployment is that it usually prevents downtime. While we are updating one server, the others are still up and running, serving our users. Yeah. Another advantage is
to use a load balancer to distribute the traffic around. That makes sense.
Is that we can spot and mitigate any issues early during the rollout.
You do that with all these. You put the canary out there, you put the Big Bang out there, you're going to know pretty soon.
Reduces the risk of widespread problems.
I guess it's like the more users you have, the more you have to be careful of this stuff. This is really what the bottom line on that is.
We're only ever exposing a small part of our system to the new version at any one time. However, rolling deployment is typically a slower process, and while it reduces the risk of system-wide issues, it doesn't entirely eliminate it.
Great.
If an issue slips
none of these do.
past our initial checks, it might still propagate as we update more servers. This strategy doesn't support targeted rollouts. We can't control which users get the new version during the rollout.
There'd be feature flag per user. So you'd have to set your application up to when the user logs in, it's like which features does this person get and what they don't have. I mean, that's kind of normal anyway. But just thinking about it ahead of time, right?
Users will gradually see the new version as we update the servers. We can direct the new version to specific users based on criteria like location, device type, etc. Rolling deployment is a popular choice for many teams. It balances risk and user impact in a controlled, methodical way.
But it does take someone to dedicated to pay attention to all this stuff. And usually the people writing the apps aren't going to be ones paying attention to this stuff. So this is where the whole idea of the DevOps stuff comes in. Maybe the product manager could do this. Maybe the product manager could be trained to maintain these things and monitor it and something like that. Somebody doesn't have to be writing the code for it, or monitoring all these rollout things. You have to. Once you get over 5,000 users, it starts to become a problem.
Now let's take a look at blue-green deployment. Here we maintain two identical production systems, cleverly named blue and green. At any given time, one side is active and visible to users, and the other side is idle. The active environment, say blue, serves the current live version of the application to the users. The idle one is our playground, where we can safely deploy and test the new version. Here's how it might work. When we have a new version ready to go, we deploy it to the green environment. While this is happening, the blue system is still live and serving the current version of the application to users. Our QA team then tests the new version in the green environment. This gives us a chance to catch and fix any bugs or issues before they reach our users. Once the new version in the green environment is deemed ready, we simply switch the load balancer to redirect traffic from the blue environment to the green one. Users are seamlessly transitioned to the new version.
It's like a big bang, except you've already been testing in that environment. And so, okay, that's pretty clever.
Of the application with zero downtime. Now the blue environment becomes idle and serves as a safety net. If we encounter any issues with the new version, we can quickly switch back to the blue environment, effectively rolling back the previous version. While blue-green deployment allows for seamless...
That's if you make sure there's no database schema changes, right? And the blue environment still has access to the old database in the same way as the new one did. Woo! It gets a little hairy.
Transitions for an easy rollbacks. There's a catch. Just like the rolling deployment, we can direct the new version to specific users. The switch from blue to green happens for all users at once.
It
is also resource intensive. Maintaining two identical production environments doubles the infrastructure and resource needs.
Yeah.
We could spin down the idle environment between deployments.
Unless you're doing on-prem, which I recommend for if you're doing less than 5,000 users, definitely should be on-prem for your application. Now your S3 buckets, all your data storage stuff, maybe that could be put someplace else. But think about on-prem in RAM database. That may be more effective than having a cluster of microservices. Like it's just having a monolithic that accesses a RAM database is pretty slick, man. It's like how many months of AWS services does it cost? A couple months, 3 months, 2 months. Some people, depending on how they're using it, could be a lot less. And it's like on-prem is where it's at for small businesses, so you can control those costs.
But this introduces complexity. Managing two parallel production environments and ensuring seamless data synchronization can add significant complexity to the deployment process. It requires sophisticated infrastructure management and tooling. However, with its high level of control and minimized risk, blue-green deployment remains a popular strategy for smooth user experience and reliable rollbacks. Next up is canary deployment, named after the age-old practice of using canaries in coal mines to detect dangerous gases. If the canary was in distress, miners knew it was time to evacuate. Similarly, in software deployment, we use this strategy to test our air before the full-scale rollout. Here's how it goes. Instead of deploying the new version to all servers or users, we choose a small subset, our canaries. It can be a percentage of servers or a group of users.
I mean, these are all kind of variations on the same thing, right? You want to roll out to a small number of people and test them out, and then if that doesn't work, then you could roll back, and then if it works fine, keep going. Okay, that's enough of that stuff. Let's go back here and listen to more.
And when you commit code and you merge into the development branch, it's automatically triggered and applied to the development environment. That means you need to have, at the very least, 4 different servers, possibly 8, because you might want to deploy the application itself and its database on 2 different physical machines. If you go to Azure, that would be like $200 for a VPS and a MySQL server. So now you need to duplicate these 4 times. You're up to $800 a month, right? Because you need one set of MySQL and VPS for your dev environment, one for your QA, one for your staging, and one for your production. Now you're paying $800. Now, I manage roughly 50 pods. From purely a practical point of view, each of these pods are basically their own VPS, and I can put anything I want onto them, but they're all containing Magic. And Magic is using SQLite.
Magic is his platform he wrote,
which would be more than sufficient for this particular job. 35 of these are pods for actual clients of mine that are paying me. And I'm running this for less than $300 a month. Because of that, I'm using Kubernetes. So I'm managing 35 live production environments for clients whom are paying me for less than $300 a month. Let me show you how I would solve that problem using my software system.
Okay, I'll let you look at that. But basically the idea is like, hey, we pay a lot for these damn things. And maybe there's ways of doing it so you don't have to use these environments and you can still build that stuff up. Let's see, who else are we seeing? So here's the kind of person that loves to build these CI/CD pipelines. And the CI/CD stuff is the kind of things like, if you get away with not doing it and just trusting your developers, that's way better than using these services, because of this type of person. I know if you, I don't know how you care about Sam Hyde. He's a very controversial person, but this take I agree with.
The other type of person that is a no-no for working with is people who are in love with problems, meaning like the engineering of the work problem. There's this psychological thing that people do. It might be called like competence validation or something. I don't know what the term is, but it's like if you're good at something, there's a pleasure to repeating it over and over again. And this is what happens with video game players who are good at like Dota and games that are like technical, probably shooters too. It's like your the sense of validation you get from doing something rote.
Right. So setting up these CI/CD pipelines is rote. Once you've set up one, which I've set up several, you can set up any one of them. But it seems very, if you've never done it before, you're in for like a world of hurt, because there's a lot of stuff you got to know how this stuff works and why it works. Everything's a little different. You got your keys over here. You put your API and the thing over here, and you're doing this environment pulling from this thing and this commit level, all this other stuff. It's nuts. It's nuts. I've set several of these things up, but once you set one up, you've gone over that big hump. You now have a valuable skill for a lot of these dev shops, because they don't want to do that big hump, because it is a hump. It is a hump. They don't care what anybody says. These systems were not set up for people, regular people, to set them up. They were set up for people that looks like they were trying to go super fast, get this particular problem solved, tape it together, duct tape, and then keep moving. And they should be avoided until you actually have to have them, right? So which is like teams of like 15 people or 10, 15 people that are all doing something on some big legacy project, and you need to make sure no one's going to screw everything up, because everything on the legacy project was written in such a way that could be screwed up for super easily, and you need to test everything because you don't know what the hell's going on. You got too many people. Yeah, that's when you need it. I get it.
You know the ice cream guy that gives you the ice cream cone, then takes it away, and he flips it around. He takes the cone, then he gives you the ice cream, but then he puts the cone on top.
Yeah,
like that type of shit. Like shit that's hard to do, but like ultimately meaningless.
Like the IT guy.
Right.
Yeah.
Hard to do, ultimately meaningless.
Jimmy Fallon used to do that on SNL.
Yeah.
Did you backlog your thing?
Yeah.
I did that. Did you clear out your browser history? I did that. Did you format in GT4X?
Yes.
And they're like, no, I didn't. And they're
Yes.
like, move.
Yeah.
Move.
Like that guy. Yeah.
Did you do the XYZ accelerator CI/CD option in GitLab? No. Move.
Which is a problem guy.
And that's anybody who's good at something has the danger of falling into that.
Mm-hmm.
Oh man, these people who love to do this DevOps CI/CD stuff are totally these characters. Move. They've mastered some crazy esoteric thing, which is CI/CD pipelines are very nuts and goofy. I mean, Bitbucket's all right, but they're all bad. All right, the way they set them up, the things you try to do with them, to try and set things up properly, getting UI tests to run on them. What? Don't even try that. You're asking way too much. Back-end tests. Oh, I think this test-driven development stuff, it's like it's mostly like back-end engineers that are super hyped about it. Well, it's like, yeah, you kind of have to write it like that, man. But front-end, we're not going to write the test first and then do the UI code. What are you, nuts?
But that happens a lot with computer art type work, because there's a lot of stuff that's not actually creative. It's just sort of like button pushing. Have you ever seen someone play with a synthesizer for the first time, or any time ever? Like if you're playing with it, like you're twiddling knobs and like finding a noise that you like, and it's like it feels like you're doing fucking NASA work, but you're doing nothing. Yeah, you're basically just
you're in Notepad on a computer that's not even on a server.
It's not even on.
Yeah. You're drawing like a circle in like mouse pad.
Yes.
Somewhere, and that doesn't even matter. Might as well be in the fucking metaverse at this point.
So there's a lot of it's easy to fall into stuff that feels like you're doing work, but you're actually either just knob twiddling and changing settings, which that doesn't piss me off personally. But what pisses me off personally is
I love learning how to do this, set all this stuff up, but wanting to maintain that and write application code and work with the customer's requirements, it's like, oh man.
When people they fall in love with the problem to the point where they don't want to solve it.
Right. Right. CI/CD is is the people that love it, is they fall in love with a problem, which they don't actually solve it. You're not actually solving it. You're adding another major increment of complexity to an issue to make for your job. I get it.
And it's like, you know how building a house is like satisfying.
Mm-hmm.
It's like if you finished the house and then I came back like 6 months later, I was like, so Nick, how you doing? And you were like, well, I'm just redoing this chimney here because it was so much darn fun the first time. Like you build the house again after it's built. People do that with computer work. People do that where they'll just like become obsessed with how difficult, and they'll start to worship the fucking problem.
Yes, I know what you're saying.
Like, oh my god, this is the most amazing. Oh, look at that, a new difficulty. And then
do you think it's people's fascination of their own skill set, or maybe the distance they've come from not being able to do that?
It's a combination of the skill set, how esoteric this stuff is to get, and how hard it is to get it right, and how difficult it is to diagnose when things go wrong, what went wrong, and how to fix it. It's just ridiculous.
Partially that, and it's partially just not being. They're not looking at it from a third person perspective. There's this thing that Gordon Ramsay says called being a busy idiot. You're being a busy idiot right now. It's like if you're peeling tomatoes. The dish doesn't call for tomatoes. Why are you peeling them?
Yeah.
It's because peeling them, there's like an OCD pleasure to like watching the skin come off, putting the tomatoes in a row,
cathartic.
mash the tomatoes into a gel. Oh, this is so much fun. Watch it boil and bubble in the cauldron. Oh my goodness, this is so visually beautiful. Look how red the tomatoes are. Smash them. The dish doesn't call for tomatoes. What are you doing? You're wasting time. No, I'm not. I'm organizing my kitchen. People like lie to themselves about how it's useful.
Yeah.
That type of thing.
That's a lot of people in these startups go, oh, we got a CI/CD pipeline set up. But they set this up without trying to get the customer requirements, trying to get any customer needs, figure out what your product is, product market fit. Never heard of it.
I think it's like no one would ever tell them like just start another one, start another project,
Or just solve the problem.
or like yeah, okay, you want to like rebuild the carburetor again,
yeah.
Don, on your 280ZX, like no problem, buy a broken carb on eBay and rebuild it if you fucking love it so much. Like, what the fuck? Like, who taught you how to work?
Well, it's like that type of thing. And then it's like that person doing it, he won't even realize the value of having like reliable transportation. It's people with project cars in their
Right. You won't realize what the real value is that you bring. It's not a CI/CD pipeline. It's solving the customer's problem, getting the app in his hands as fast as possible. Hearing what he needs to do, figuring out how to make it work, getting it in a form that the customer, and then getting the customer to look at it without and trusting the people involved, because you're going to probably be that person that you're delivering the right thing, and you've tested it out, and you've tried it out, and you've set your application up. So if I just poke on this thing, I'm not going to destroy this other part of the program. Or I've got some sort of testing set up already because I know that that's a possibility. So I've got a testing set up for that, and not overdoing with a CI/CD goddamn pipeline. And to do tests, you don't have to have a CI. I know this is a shocker. You can do tests local on your machine. I know. And you don't have to do a test for every commit. And you can do it if you're going to do a major build to get it up. Then you do your full-on test. You know what? It's not. It has to be so. You must do thing X to get a Y to Z, and it's like you have to do A, B, C, D, F, G. No, you don't have to do the whole alphabet. You can do X. You do A, J, and Z. Then you can skip over all the other stuff. That's for another company, another time, and in the future, maybe when you're not even going to be there.
their yard for years.
Yeah.
That's the type. That's the person.
Yep. And they'll never get checked. And you want to know why that's an uncheckable? Like, I would never stop you, right? Like, I would never be like, Sam, why are you doing that? Why are you fucking, I don't know, like my dad does stuff like changing the, I changed the tires again. Like, for what? Like, for what? There's no, it's like just it's like busy work. It's like because you can, but because no one said like, hey, why don't you develop a skill set where you make an outline on something and complete the other things that you could probably do, and maybe knock some of those off or learn a new one, maybe something you haven't done yet.
That's scary. That takes risk. That takes risk and courage and creativity. If you've set up a CI/CD pipeline once, you can definitely do it a lot, and you'll be very impressive to anybody that hasn't done it yet, because it's just all this stuff is nuts. But you're avoiding the quest, man. I get it if you're at one of these tunnels of fake Agile Doom, Scrum Coach, Death March, Cargo Cult. Yes, Cargo Cult the shit out of it. Oh, you've heard of CI. I went to the conference. I bought the book. I got to get the CI/CD pipeline in there as soon as possible. It's like, no, you don't even have any customers yet. You've got more servers than customers. So no, until we get some customers, no more servers. You get a server, it's on-prem, and you forward your IP through a NAT port to your local thing right there, and you're saving money because you're running on a Raspberry Pi because you only got 500 customers anyway. And that's fine for what you're doing. Oh my gosh.
There was one of those kids I used to work with, and I went to a wedding with the kid. I went to a wedding this weekend, and I had the first time where I got confrontational with someone in like 5 years. There was this little fucking pud in the back. His name was Matty P. And I was like, I was cocked, and I was like, I'm gonna fucking tell this kid off. He used to just make my life a living hell. He was a parts manager. So say like you came in, I need to get like a wiper blade, but it was a rush. Like you were like, Nick, what the fuck? You just sold me a car. Fucking wiper just flew off the back. It happens. I have to go to parts. I have to grab a wiper blade. So give me come on, dude, I need a PO. Now I have to go to another person, get a purchase order, come back to him. Instead of just being, I'll get it for you after they leave. I have a hysterical in my fucking like yelling at me that we make piece of shit cars, and he'd be like, nope. He's my age. And he's like old enough to know, like he's like a cool beer drinking pud. But like he's cool enough to know like how much of a fucking he's being. So I was like, Matty, he's like, hey, and then he came in and he gave me, you know what, I hate fake empathy. How you been, man? I'm good. You happy you're not working anymore? How you doing? I'm doing all right. And then he said, I'm really glad to hear that you're doing good. I go, you know what, Matt? Why don't you go fuck yourself? And he's like, what? And I was like, yeah, dude. I was like, you're a fucking. And he's like, what do you mean, dude? I was like, you know what, man? I was like, you don't give a fucking shit about me. You don't give a shit about the fucking shit. You busted my balls for like 3 years. You're lucky I didn't fucking beat the shit out of you, to be honest with you, because I'm a piece of fucking shit. And I was like, the old me that gets punked off by guys who are smaller than me, I'll just slap you in the fucking face and I'll make you do something. I'll wait till you get out of work and I'll slap you in the fucking face, like standing right in front of you. And I was like, and he's like, whoa, where's this coming from? And I was like, I don't like you. I was like, I don't like you. No one you work with likes you. You're a pain in the ass, and you know better.
Yeah, don't be the first guy to recommend, hey, we get a CI/CD pipeline set up in here. It's like, no, stop, no. We're just going to build on our machines with the minimal set of tests and minimal end-to-end thing with the screenshot thing turned on, so we don't have to write the damn thing and update the damn thing. And we're not going to do all that crazy shit. We're just going to get our customers and keep going.
The problem. You're a smart guy. I've talked to you about beer before. I was like, you know what kind of guy in the movie you are. You're like a little fucking head. And then your own guys that you like are fucking losers. Your boss, Lance, is 42. He's got a Wolverine tattoo on his forearm that's 1 year old. That's fucking You're a fucking And my boy Jeff heard it, who works with him, like right with him. He's like, like he can't believe it. And he's a big kid too. Like he'll slap him around too. So it's not like a fight thing. But I'm like, you need to know that you got to change the way you fucking are. Because that whole like, I'm gonna do that. Like you're gonna fucking die of cancer. And no one's gonna know your fucking name. And singing me this like managerial response that you're trying to give me right now, buddy, blow it out your fucking ass. That corporation sucks. Roger Penske's a fucking loser. And I was like, and Manny, like, dude, you're like a piece of shit from West Warwick like me. Like you're a scumbag. Don't give me this canned speech like, well, I'll try to do. He tried to say like, well, I'll try to do better in the future. Like I don't give a fuck what you do. You can come in a cup and drink it for all I care. But don't ever fucking come at me like that. I was like, fix how you act. Leave upset tonight. Wake up tomorrow and be better.
That's what I gotta say when you bring the CI/CD. And here's the sentiment from Steve Wozniak, the creator of Apple I, Apple II, talking about how he got color on the color computer. He went the opposite direction. People are saying, no, you gotta have 65 chips and 25 other things, and it's impossible. It just takes a massive amounts of RAM, and RAM's super expensive, and you can never do it.
The idea came. Luckily, it either comes to you or it doesn't sometimes to solve these things, like putting color into computers. That was probably one of the biggest things Apple ever did. Nobody expected color to come into a computer because color machines cost $1,000 to generate color. They had tons of chips, and
Back when $1,000 meant something.
I figured out a way to do it with one little $1 chip. And it was really strange how it happened. But this would apply to young children. I was without sleep for 4 days and nights because Steve Jobs and I got a project to design a game for Atari called Breakout. He said, Steve needed the money quick, so we had to do it in 4 days and nights. I didn't think it was possible.
He was going to Steve Jobs needed to go. He was going to join some cult for the weekend, and they needed a down payment to join in the cult. And the cult thing was starting in like 4 days. That's why he told Woz he had to do it in 4 days, because he was joining some cult and going to go eat apples for a month.
Back then, games weren't software. They were hardware. Little chips and voltages to wires from here to there make it work. And I didn't think it was possible, but I said, I'll try it. And I designed the whole thing, and we got it done in 4 days and nights. But when you're without sleep, when you're going to sleep, your head goes briefly into this period of really creativity, kind of thinking. It's not restricted to the normal thoughts of life and the day. When you're waking up, your head's a little like that. Well, my head was kind of in this floating, half-asleep state. And out on the Atari floor, they only had black and white TVs in those days for the first arcade games. They had this dot going across the screen. It's changing colors like a rainbow. And it was hypnotizing like you're at a concert or something. And they just put little strips of Mylar, red, green, blue, yellow, on the TV screen to do it. And I started thinking, that's so beautiful. And I remember exactly what bench I was at. Steve was wiring up the board over there, and I'm right at this one bench. I just started drifting, and I thought, signals for color TVs. I remember from high school electronics, they go up and down at a certain speed. And I thought, what if you made a signal that went up and down at a different rate? Would it look like color? Just a digital, the normal simple thing I can do with almost...
The normal simple thing I could do. The thing that he could do without $1,000 chips, without 16 different chips that cost $8,000, whatever it was back then. What he could do with his imagination, sitting back, goofing off, not doing his fucking job, not doing the code and doing the he was just back over here, and all of a sudden he went from black and white to color. See, he's concentrating on the things that move the needle, not the stuff that is like not more digits on the not more diodes. It was more going off into space and watching the TV go back and forth and going, wow, that's really amazing how that would work. And then, boop.
No parts at all. Would it look like color? And then, oh my gosh, I figured out a way that I could have four little 0-1 bits circling around, and it could go up and down at different time, and red would become blue. I could put in a different pattern of ones and zeros. I had 16 patterns, and it could become a different shade. It might be a little lighter, and it might be a little darker. Would it work? And didn't know. But when I finally wired it up about a year later, and brought Steve over, we saw it, and that was eureka.
How couldn't he do that in a sprint? Why didn't he do it in a sprint? He should have been able to, the moment he realized what it was, he should have been able to do it in a sprint, because that's how long it takes for this stuff to come to fruition. A lot of stuff is luck. A lot of this stuff is serendipity. What happens if Steve Woz had never had that assignment, and didn't wasn't at working 4 days in a row with no sleep because Jobs wanted to go join a cult, and he got to make this down payment, that he would be sitting there in Atari for all those hours watching that thing go back and forth, that he was able to create color on the computer when no one else even thought it was even possible. How do you put that in the sprint? How many points on that ticket?
He knew this was a big change in the world. So sometimes you're not sure if it's going to work because it didn't follow all the methodology, all the science that's in the books, all those numbers, yet it's similar enough it might work. And in this case, it did.
Yeah. So that's kind of the attitude that you kind of have to have about CI/CD. And and this is the kind of things that people do. Like, you're going to need the CI/CD pipelines later after you get more people to come in, and you already got a product, you already got people, you got your customers, and you're already making money. Then the CI/CD pipelines may be necessary because you got new people coming in. You want to check their code, make sure they're not doing anything weird, etc., etc. Give me a like and subscribe, and I'll talk to you soon. I'm Chris. Oh yeah, tech sports coming out Tuesday. Fix that.